Can a computer operate without using electricity for computation? Theoretically, yes. In practice, hybrid systems are already emerging where light takes over some tasks traditionally handled by electronics. Photonics could redefine how we build and scale computing systems. Conventional computers rely on electronics. At their core are transistors, tiny switches that control electrical current to perform logical operations. But this technology faces several physical limitations. Energy consumption. Packing more transistors into a chip increases heat output, especially in data centers. Speed constraints. Electrical signals travel slower than light and suffer from resistance and capacitance in wires, causing delay and energy loss. Scaling issues. As components shrink to the nanometer scale, quantum effects like electron tunneling begin to interfere, making it harder to ensure reliable switching. These issues have led researchers to explore alternative approaches, and light has become one of the most promising. One area where photonics is already essential is data transmission. Optical fibers have replaced copper cables in long-distance communication, data centers, and backbone internet infrastructure. Photons in optical fibers travel long distances with minimal signal loss and no electromagnetic interference, offering much higher bandwidth than metal wires. Optical communication is already enabling data transfer speeds of hundreds of gigabits per second. Despite these successes, building a fully optical processor remains unsolved. The core challenge is the lack of an optical equivalent to the transistor, a device that can reliably switch one light signal using another, with speed, efficiency, and scalability. In electronics, transistors amplify signals and perform logic in nanoseconds. In optics, we don't yet have a compact, energy-efficient, and fast device that can do the same for light alone. Experimental logic gates using interference, nonlinear materials, or photonic crystals exist, but none have the robustness or scale of CMOS transistors. While fully optical processors don't exist, specialized photonic chips have already been built for tasks like artificial intelligence and matrix computation. Companies like Lightmatter and Lightelligence develop photonic integrated circuits, PICs, where light is used to perform mathematical operations directly. These chips don't replace CPUs, but act as accelerators, working alongside traditional electronic systems. Optical computing offers key advantages: light speed propagation, parallelism through wavelength division multiplexing, and minimal heat dissipation. But practical photonic computing still relies on electronics for control and requires highly specialized components. Key challenges include miniaturization, manufacturability, and stable integration with digital infrastructure. Still, hybrid systems, combining electronics and photonics, are already in use. Fully optical computers may become viable as materials science and nano-optics continue to advance. A computer that doesn't rely on electricity for logic isn't just a fantasy. It might be the next step in computing evolution, and photons are already starting to take over from electrons. If you want to keep up with how computing, AI, and technology are evolving, subscribe to TechFacts. New facts every week.